In this tutorial, we'll remind ourselves of some of the basics about graphs. We'll start with the simplest thing, graphing a straight line. As you may recall, the expression for a straight line can be written as y equals mx plus b, where m denotes the slope of the line and b denotes the y-intercept. Let's look at a specific example here. Suppose we have y equals 2x plus 3. So this is an expression for a straight line whose slope is 2 and whose y-intercept is 3. Now let's remind ourselves, what does the y-intercept mean? That means when the value of x is 0, imagine plugging in 0 here, then y equals 3. So in other words, the y-intercept, this expression here, or if you like more generally this expression, is simply the value of y when x equals 0. So if we make this plot and we look over at x equals 0 here, and we look at the y value, we see that y equals 3. So that's where the straight line hits the y-axis. That's the meaning of the y-intercept. Now let's look at the slope. In this example, the slope is 2. Slope, you may recall, is rise over run. So let's go to a point on the graph, let's say this point here, and what it says is if we go 1 unit over, we must rise up 2 units in order to remain on the graph. So for every 1 unit we go to the right, we must go 2 units up. Let me put that in here so you can see that a little bit more explicitly. So here we see, I've drawn a little triangle here, and for every 1 unit that I go over horizontally, I go 2 units up. So the rise over the run, 2 divided by 1, that defines the slope, and that's what this number is here, 2. If, for example, we change the slope, and instead of plotting y equals 2x plus 3, for example, we change the slope to 4, so y equals 4x plus 3, then the line would become steeper than before. And in fact, it would look something like this. So this is a plot of y equals 4x plus 3. The only difference between here and here is that the slope has become larger, 4 instead of 2. So that means for every 1 unit you go over, you've got to go up 4 units to remain on this line. Next, let's suppose we have 2 points on a graph and we want to determine the distance between them. Let's remind ourselves how we do this. Let's illustrate with a specific example. Suppose I have a graph here and I've marked 2 points on it. This point here, whose coordinates are 1, 2, in other words, x equals 1, y is 2, and this second point here with coordinates 4, 7. Suppose we want to determine the distance between those 2 points. In other words, we want to know what is this distance right here. We'll figure this out by drawing a simple triangle. So consider this triangle that I just drew. It's a right triangle. And notice that to move from here to here, we have to go from the x equals 1 position of the first point to the x equals 4 position of the second point. In other words, we had to move over 1, 2, 3 units. To move from here up to here, we're starting at a height of y equals 2, the y coordinate of the first point, and we have to climb up all the way to the 7, y equals 7. So in other words, we had to climb up 1, 2, 3, 4, 5 units. So in other words, this distance, the horizontal distance, is just the difference between the 2 x values or x coordinates of the 2 points, and this vertical distance is simply the difference between the 2 y values. 7 minus 2 gives me 5. From the Pythagorean theorem, we see that the length of the hypotenuse of this triangle is simply the square root of 3 squared plus 5 squared, which is the same thing as the square root of 34. So that's the hypotenuse, and that is the distance between these 2 points. More generally, if I have 2 points, the first with coordinates x1, y1, and the second with coordinates x2, y2, and I want to know the separation distance between them, namely that distance, I will again construct a little triangle here. The length of this bottom leg, this one here, is simply the difference in the x-coordinates, x2 minus x1. And likewise, the length of this side is just the difference between the y-coordinates, y2 minus y1. Therefore, the length of the hypotenuse, which is the distance between the 2 points, that's what we're looking for, is simply x2 minus x1 squared plus the difference between their y-coordinates squared. And there you have it. This is the distance between 2 points. Lastly, just a quick reminder that sometimes you'll be making plots that aren't just simply straight lines, or not simply finding the distance between 2 points. For example, you might encounter a situation as follows, where you're going to make a plot of y equals x squared. So notice that this is a quadratic function because it involves an x squared, not the linear case like mx plus b that you encountered previously. This is a quadratic function, so the shape of the graph will not be that of a straight line. It will look a little bit different, and in particular, it generally looks something like this. Depending on the specific nature of this function, sometimes it can look slightly different than this. It might be a little bit more elongated or a little bit narrower, or sometimes even turned on its side. But this is generally the shape of a quadratic function.